Hello students. Now we are going to discuss some important organic reaction mechanism, dehydrohalogenation of haloalkane, and that is also Williamson synthesis. Dehydrohalogenation of haloalkane, that is elimination mechanism. Elimination generally we know it is maybe E1 or E2 mechanism. E1 mechanism means mainly highly substituted haloalkane will be used. For examples, if you take CH3 whole 3 CBr in presence of alcoholic KOH, the product is CH3 C double bond CH2. This alkene is formed. So how tertiary butyl bromides convert to isobutene? This is called isobutene. How it will convert this one? Let us discuss the mechanism by E1 mechanism concept. We know E1 mechanism means the first step is the formation of your carbocation. First what happens? This CH3 CBr undergo loss of Br minus forming carbocation and Br minus. This is the first step, and this step is, you can say, it is slow step. It is the slow step, formation of carbocation. Then that means rate determining step. Rate determining step, RDS. The rate determining step, that is formation of carbocation. In the second step, what happens? This carbocation attacked by base, that is strong base we can use, potassium hydroxide, sodium hydroxide, base having OH minus. Then what happens here? This step is also first step. In the first step, this OH minus takes protons. The proton will be taken by OH minus. Then this bond convert to double bond, that is pi bond. This CH bond, the H plus will be taken by OH minus, because OH minus acts as a base now. Then after the deprotonation, then what happens? This bond is converted to pi bond. So formation of alkene. Alkene means isobutene occurs. So this step is the slow step, second step is the fast step. So the rate will be is equal to K, and concentration of substrate as this rate determining step, that is slow step. So this, for all E1 mechanism follow the formation of carbocation. So you have to see in which case the carbocation is stable. It is stable. So in which type of substrate you will use so that carbocation will be stable, you have to follow this one. And in case of E2 mechanism, where it is a two-step process, it is one-step process, it is a two-step process, it is two-step process, two steps, but it is one-step process. Attacking a base and releasing of living group will be takes place in the same time, simultaneously. We have to see this one. So let us take the example here. Mainly a primary group, that is less bulkier group, will take part. Let it be CH3 CH2 Br in presence of alcoholic KOH. Here alcoholic KOH acts as a base. Here alcoholic KOH acts as a base, and formation of alkene plus your KBr and plus water. Here also same, formation of KBr plus water. Here what happens? This OH minus will take and produce water. That will not be necessary to show in the reaction. Okay, let us discuss the mechanism. Here what happens? The attacking of base and releasing of leaving group occurs simultaneously. That is one step process. You have to take like this. Here attacking of base OH minus will attack, and here the group is like this, H, then C has 2, this one C has 2 and here, and always the base attack the carbon atom and the release of leaving group both should be in antiposition, that means transposition. Here what happens? Attacking of that base, loss of H plus will occurs, at the same time formation of pi bond and releasing of group will occurs simultaneously. So this step, that is one step process, it will proceed in transition state. Transition state we can write like this. Here OH minus dot that H CS2, then single bond CS2 dot Br minus. Here it will be as H plus, it will be as Br minus. And here what happens? Formation of pi bond will occur. So this is called transition state. Formation of that loss of H plus and loss of Br minus occurs same time. This H plus will be taken by base. Attacking of base and releasing of leaving group occurs same time with the transition state. So the result will be formation of that CH2 double bond CS2 H plus, then Br minus. Here Br minus and available K plus become KBr. It will return. Then the H plus will taken by OH minus, forming water. So this is the mechanism. This step, here there is no slow step and fast step. Generally it is one step process, and this is attacking and releasing. Like your SN2 mechanism. Attacking of nucleophile, releasing of leaving group. Here attacking of base. Here it is called base. It is not nucleophile. OH minus acts as a base. It undergo deprotonation from the substrate and the loss of leaving group and formation of pi bond. So this is alkene, ethene. This is called E2 mechanism. So which is E1, which is E2 depends upon the nature of substrate. If primary, that is E2 mechanism, is tertiary, that will be E1 mechanism, formation of stable carbocation. This is the concept of E1, E2 mechanism. Then another important example, nucleophilic substitution reaction, that is Williamson synthesis, mainly SN2 mechanism. Here what happens? Let us take CH3 Cl plus CH3ONA, formation of that CH3 or CH3 plus NaCl. This case, but formation of ether. Formation of ether. This is your haloalkane. Chloromethane, and this is your that alkoxide salt. Alkoxide salt and produce ether. And this mechanism purely SN2 mechanism. Here the nature of, in Williamson synthesis, the nature of haloalkane should be primary. If it will be primary, the result of formation of ether will be favored. So we have to take care of this thing. Always we have to use haloalkane should be in primary nature. Let us discuss the mechanism. Here mechanism will be that as it is SN2 mechanism, both attacking of nucleophile and release of living group is same. For example, here what happens? CH3O minus acts as nucleophile. It will attack that the haloalkane carbon, it attacking of the nucleophile to the electron deficient center of this carbon, then loss of living group takes place, and it occurs attacking and releasing occurs at the same time. That means it proceeds in transition state. We can write like this: CH3O minus dot dot dot, here CH2. CH3 you can write, better you write in transition state, it will be better. You write in transition state. It will be like this: same C attacking and releasing. We have to show in transition state. This is called transition state. All transition states should be written in the bracket. Then what happens? Result the formation of what? The ether. How ether is produced? Already CH3O is attacking to CH3. Then loss of Br minus. So this is your ether. Here it is one step process. It is shown in this in the form of transition state, but attacking and releasing in one step. So here rate will be K in the concentration of substrate and the which one? Nucleophile, that is CH3O minus. Both concentration is depends. That's why this is called SN2 mechanism. Bimolecular, first unimolecular and second one unimolecular, result to bimolecular. It depends upon concentration of haloalkane and concentration of nucleophile RO minus. That's why it is SN2 mechanism. So you have to take care of this, which is SN2 mechanism, which is SN1, which is E1, which is E2. We have to think on the basis of the nature of substrate and the nature of reagent used during the reaction. So you have to think accordingly. Okay. Then we now will discuss other mechanism. You complete this one. Okay. Next we will discuss nucleophilic addition. Generally this nucleophilic addition is generally shown by aldehyde and ketones. Let us take one example. That addition of ammonia and its derivative to aldehyde and ketone. Let us take one example. CH3 HC double bond O with ammonia derivative, in presence of slightly acidic medium. Remember, a slightly acidic medium is required, not strong acid. In case of highly acidic, the reaction will be very slow, reaction will not take place. Then product is CH3 HC double bond N G. This is the product. What is the mechanism? Here mechanism like this. CH3H, this keto group will be protonated by H plus ion. It will be protonated, then producing CH3HC double bond OH plus. It will be protonated. This protonation, due to this protonation of keto group, then oxygen becomes positive charge. This OH group becomes positive charge. So what happens? This breaking of bond will be easier by the attacking of which one? Nucleophile. NS2G. Attacking of nucleophile. And the nature of nucleophile depends upon G. If G will be electron donating group, so it will be better nucleophile. If G will be electron withdrawing group, the nature will be slow, the reaction will be slow. So that depends upon the nature of G. So what happens? This nucleophile will attack to carbon atom, then breaking of this pi bond takes place. Then what happens? This CH3 and the C, then NH, G remain, then single bond OH takes place. And here after donating lone pair, it becomes positive charge. Then what happens? Loss of proton, that is takes place. Loss of proton takes place. Loss of proton takes place. Then the result is CH3, HCOH. Okay. Then become NH and G. When it will be loss of protonation, that is deprotonation and protonation both, and plus H plus. What does it mean here? One side H plus is removed and the same H plus is added to adjacent OH. So what happens? Become OH2 plus. This H plus after losing from NH, then it is added to OH. Then become OH2 plus and become NH. Then what happens? This one here, loss of H plus, formation after loss of H plus become formation of pi bond. At the same time, loss of water takes place. That means we can say deprotonation and dehydration. Deprotonation and dehydration occurs, resulting formation. That means elimination. This case is elimination. This case we can tell elimination reaction. This is the elimination reaction. Loss of H and loss of OH2 plus. So formation of product CH3, HC double bond, N, H, N and G. This is your product. This is your product. That is called what? Substituted derivative. That is amine derivative of aldehyde ketones. It depends upon the product name. Depends upon the what type of substituted amines are used. So here the main, that is protonation. This is called protonation. You see addition of H plus, that is protonation. Protonation reactions. Then attacking of nucleophile to the positive charge center carbon. Then here what happens? Protonation and deprotonation both. This is deprotonation and protonation. One side proton is released, then at the same time it is added to OH. So deprotonation and protonation. Here what happens? That deprotonation and dehydration. That means loss of hydrogen and loss of water takes place. That is elimination reaction forming the product. So in nucleophilic addition reaction of aldehyde ketone results both that attacking of nucleophile, then loss of molecules resulting in the formation of what? Alkene. So this is regarding nucleophilic addition reaction. But esterification, let us take the example. Esterification is known. Acid reacts with base. Acid reacts with alcohol in presence of acid sulfuric acid, producing ester. What are the mechanism? Here, different mixture of mechanism involve nucleophilic substitution, and many nucleophilic substitution reaction also takes place. Protonation, deprotonation, different steps involved. First step, what happens? First protonation. Acid, first it will be protonated, undergo protonation. Formation of protonated acid. It will be protonated acid. Clear? Then it helps the attacking of which one? The alcohol. Here alcohol acts as a nucleophile. Here it acts as a nucleophile having lone pair attack to this carbon atom. And same time breaking of bond takes place. So what is the result? CH3, COH, then here OH, then OH, C2, H5. Here results the formation of positive charge after donating lone pair. Then what happens? Here deprotonation takes place from here and gets added to OH. Then the reaction will be, what happens? CH3, COH, then OH2 plus after addition of H from here to that side. Just transfer of H to another place. That is, here it is called deprotonation, here it is called protonation. Both occurs. So result O, then C2, H5. Then what happens here? Deprotonation takes place. Here deprotonation occurs. How? Like this. Loss of H plus and loss of water. That is here deprotonation and dehydration. Loss of hydrogen and loss of water takes place. Results the formation of what? CH3, C in double bond O, then remaining O, C2, H5, then ester. So fast protonation, then the protonated product will attack by nucleophile, then transfer of, you can say transfer of H plus from OH, that is from one oxygen to another oxygen in the same molecule. And in the last step what happens? Loss of hydrogen, that is deprotonation and dehydration, that is elimination reaction. This is called, you can say, elimination reaction. Loss of water, loss of H, so formation of double bond. So ester is, lastly ester is produced. So this is called esterification, and this reaction is reversible. Both the reaction is reversible, and as it is a reversible reaction, the reaction speed can be increased by the loss of ester or water from the medium. If you remove water from the medium or that ester from the medium, then the reaction will be faster. So this is regarding esterification and nucleophilic addition. Here the nucleophilic addition involves both addition and elimination, both reaction takes place. Okay, so in practice, next class we will discuss more mechanism regarding the other chapters. Okay, thank you all.